Chapter 7 extension, or about 7.9 as far as the section goes. In this section, we are going to use something called the law of sines and cosines to help us find missing angles and sides in non-right triangles. But first, let's go back and review what we did in 7.7, 7.5, and 6 using right triangle trig. So see if you can solve this triangle. And then once you've done that, then you can listen for the explanation. So, if you got the answers correct, then you should have these values. Now, there are more than one way to solve some of these, so you could get slightly different answers, but you should be awfully close. So you can see the work here that we did, and I chose to use the Pythagorean theorem for finding the side length, but of course you could use right triangle trig as well. So, in this extension of Chapter 7, we are going to learn about the law of sines and cosines and then use them to solve the triangle which we just got done doing with right triangles. The difference is these are not right triangles. So let's look at SOHCAHTOA again. Remember, right triangle trigonometry. That means it has to be a right triangle. But what happens when the triangle is not right? Well, then you can't use SOHCAHTOA. You can't use the Pythagorean theorem. But you can use something called law of sines and law of cosines. And we're going to focus first on law of sines. And the nice thing is these law of sines and cosines work for any kind of triangle. You could use them in right triangles if you want, but they're more complicated, so that's why it's just easier to use sine, cosine, tangent, and their inverses and Pythagorean theorem. So, law of sines. If triangle ABC has side lengths A, B, and C, as shown, then the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is also equal to the side of sine C over side C. So this right here is the law of sines. Now, notice how the triangle is labeled. It's important. So angle A and side A are across from each other. And notice they're named, the angles are all named with capital letters, and the side lengths are named with lowercase letters. Now, when we use the law of sines, we don't use all three ratios at the same time. We just choose the appropriate two fractions that we do know 3 out of the 4 pieces. So, if we are going to use the law of sines, these are cases where we can use them. We have to be given 2 angles in one side, either angle side angle or angle angle side, or you could be given 2 sides and an angle that is opposite one of the sides. So side side angle. And basically, we're going to want to try to use the law of sines anytime we can. And if we can't, it's just you're gonna naturally understand that you have too many unknowns when you set up your proportion, so you can't solve, and that's when you know you need to go a lot of cosines. Okay, so here's our first example where we're given 2 angles and 1 side. So when we say solve the triangle, the first thing we can do is find angle C right here, because we can just use triangle sum to find angle C. And so if we take 180 and we subtract 85 and we subtract 29, that gives us 66 degrees for angle C. So angle C is 66 degrees. That was the easy part. So now we can't use SOHCAHTOA because we don't have a right angle. So what we're going to do is we're going to notice that in order for us to find side C right here, we are going to have to use the 66 degree angle. So we're going to set up the sine of 66 over C, which is the side that we're looking for. That's the same proportion as like the 85 compared to the 9. So the sine of 85 over 9. So now we can cross multiply, and when we do that, we'll multiply these two together, so we get 9 times the sine of 66 is equal to C times the sine of 85. Again, I'm trying to solve for C right here, So what I'm going to need to do is divide each side by the sine of 85. So now my C value is equal to 9 times the sine of 66, all divided by 85. And you can enter that in your calculator in one step. Oops. I forgot to write the word sine in here. I've been talking it, but not writing it. So when you multiply this on your calculator, you can enter 9, then sine. Remember, you don't need the times in there. 66. Close your parenthesis on that 66, though. That part is kind of important. And then you're going to divide by the sine of 85. And you shouldn't need to put that in the sine of 85 in another parenthesis. So what we get here is that C is equal to 8.25 units. So side C is 8.25 units. Now we can't use the Pythagorean theorem to find A because it's not a right triangle like we did before. So to find side A right here, we are going to have to use this 29-degree angle. So we're going to set up the sine of 29 divided by the side with it, which is side A. And that is equal to, again, I'm going to use the sine of 85 with the 9. So again, this side right here with its matching pair. So now again, we cross multiply, and that would give us 9 times the sine of 29 equals A times the sine of 85. Divide each side by the sine of 85. So basically we're going to take this right here and just enter it in our calculator, and that is what's going to equal our side A. And when we do that, our A value is approximately 4.38 units. And again, I would be working these, you need to work these out on your calculator to make sure you are knowing how to enter it in your calculator correctly with appropriate parentheses and so forth, because you certainly don't want to get problems wrong just because your calculator keystrokes are not right. So that's how we do law of sines. So we have lots of examples in here, and this is going to get to be a pretty long lesson if I go through all of them. So I think this next one is set up pretty much the same way. So I want you to try this example on your own, and then I would like you to check back and look at the notes that I post and make sure that you've gotten it correctly. Done it correctly, excuse me. And then you can check the work if you haven't. Let's go through this one together, because now we're going to be given two sides and one angle. So now we have to be able to find that angle. We can't just use triangle sum. So for example, if we are going to find angle C right here, that's what we need to find. Well, the sine of angle C compared to the side across from it, its matching side, that's going to equal the same ratio as the sine of A right here and its matching side. So the sine of 51 over 18. So again, cross multiplying here, we're going to get 18 times the sine of C equals 17 times the sine of 51. So now to solve, we need to divide this by 18. So now what we have is we have the sine of angle C, some angle, equals this value, 17 times the sine of 51 divided by 18. We could get a decimal for it, and we're looking for what ratio, what angle equals that ratio. So again, how we solve this is we have to take the inverse sine of each side and multiply it with this. So again, this can get tricky, so practice this on your calculator. These cancel out right here. So now I'm left with C is equal to, and this is how you'll enter it in your calculator, inverse sine, then you have this parenthesis, 17 times the sine of 51, close that parenthesis, divided by 18, and then you'll have another parenthesis. So when you calculate all that, you'll find out that angle C is approximately 47.2 degrees. So one of the things we found was angle C is 47.2. Now you could go through the same process to find angle B, and maybe if you were doing a test or a quiz, you might want to do it that way just to double check, but we could also use triangle sum now. We could take 180, just because these problems are a lot of work, minus 47.2 and subtract 51, and that gives us 81.8. So we found the two angles. The last thing we need to find is this side B right here. So again, now we're going to go back and do the process that we did in the last example, and we are going to set up, we already know that this is 81.8, we just found that. So we're going to set up the sine of 81.8 compared to its side B will be in the same ratio, and I'm going to go back to use my given, the sine of 51 over 18. So when we calculate this side length now, cross multiply, and etc., I'm going to just write down that the answer here is 16.99 units. So again, you're cross multiplying, but you really could just do this means exchange. But when you cross multiply right here, your intermediate step would be 18 times the sine of 81.8 equals B times the sine of 51, and then you're going to divide. So if you didn't get that answer, this is what you needed to do. Okay, so remember when we had congruent triangles, when we were trying to prove triangle congruence, we couldn't use side, or side angle, excuse me, because remember backwards, not so good. And the reason is, if you only know this side is congruent to this side, and you know this side is congruent to this side, these are the same, but if your angle isn't included in between, what happens is, if this is your congruent angle, you don't know how long AC is. And if AC is short, then you have this obtuse angle right here. And this is smaller, AC is smaller. If AC is larger, that means you have this acute angle. And so you have two different triangles, and so you don't have congruent triangles with side angle. But we still can find missing pieces with side angle. And so when we look at side angle here, we may end up with an obtuse triangle, and that can be tricky. We're not going to focus a lot of our time on this, but when you have an obtuse triangle, what happens is after you solve it, you are going to need to go back and you are going to need to check for these things. I have that at the end of the lesson. So we'll come back to this type of example later on, but it is going to use the same process we just used. So we're going to go through one example here where we actually don't have the triangle drawn, because we're going to make sure that you can set up the triangle correctly. So if you're just given values, then what I would do is start by drawing a triangle. It doesn't matter if it matches the values you're given. So if this is A, B, and C, and you're given that B is 64 degrees, and you're given that side A is 2.34, remember it is crossed from angle A, and side B is 3.5. So now the only thing tricky about these is just making sure you get things in the correct place. What we are being asked to find here is we are being asked to find the measure of angle A. So the ratio that we're going to set up is the sine of A over side A will be in the same proportion as the sine of angle B over side B. So now we can cross multiply, which gives us 3.5 times the sine of A equals, oops, I put B in there, but I need to actually put the value where I have too many unknowns, which is what happens and you have to use the law of cosines, but we're not there yet. So then we have it equals 2.34 times the sine of 64. So now we solve by dividing by 3.5, and what that should give us is that what we end up with is, again, we have sine of A is equal to 2.34 sine of 64 over 3.5. But remember, it's an angle we're trying to find, so we have to take the inverse sine of each side. So you have to take the inverse side of everything in that parenthesis, which then gives you that angle A is 36.9 degrees if we round to the nearest tenth. So there are other examples. I'm going to have you try this piece right here by yourself, and then check back to the notes, and I will make sure that I work this one out. There's lots of examples, but I'd like to move on to the law of cosines. So the next thing we're going to look at is this law of cosines. Again, these are for triangles that are not right triangles, and the law of cosines is more complicated than the law of sines, and the math is actually harder. The algebra is actually harder. So what we want to do is we want to know when to use it, and really always try to use the law of sines first, and if you can't because you have too many unknowns, that's when you need to go to the law of cosines. But in general, you're going to use it if you're given 3 sides and no angles, because you can't set up the ratio if you have no angles at all. And if 2 sides and an included angle are given, you're also going to use it because you're not going to have the angle with the side opposite. So you can have, again, you'll have too many unknowns. But it's kind of looks like the Pythagorean theorem. If you just look at this part of it right here, looks a little bit like the Pythagorean theorem, a little different order. Well, keep that in mind because that may help you to memorize it. But basically, the law of cosines right here is there's basically 3 different versions, because basically it's going to depend on what you're given. But you really don't need to worry too much about it. What you need to think about for this formula is that whatever side squared is the beginning and equal to, it's the cosine of that angle. And then the other things are just the other 2 sides squared minus 2 times those other 2 sides multiplied together. So if you look at the next one, notice you have b squared and you have cosine of b at the end, and then you have a and c, and then minus 2ac. So they're really just the same. We just wrote it out for all the possibilities. So, example 1. It says, solve the triangle where you're given 2 sides and no angles. So this is our first one we're going to work through. All right, so if you try to set up law of sines, you would go like, oh, sine of angle A over 3 equals sine of angle B over 2.5. And notice, you have 2 unknowns. You won't be able to solve that, okay? So what we are going to do is, and I'll just kind of erase that so that doesn't get in our way, because these problems do take a little more work. So what we're going to do is pick one of the angles to find first. That's all you need to do. And so the angle that I'm going to try to find first here is just picking A. Doesn't matter. So that means I'm going to use the formula that has a squared equal, and then the last thing at the end is cosine of A. What comes in between is just b squared plus c squared minus 2bc, and then times the cosine of c. So there's a times in there. So that's the formula I use. So now I just plug everything in. So my A side is 3. So I do 3 squared equals 1.25 squared plus 2.5 squared minus 2 times 1.25 times 2.5 times the cosine of A. So now, I am going to just start multiplying these together. So this is 9, obviously. So now if I take 1.25 and square it, that gives me 1.5625. And 2.5 squared would give me 6.25. Minus, now I take 2 times 1.25 times 2.5. And that gives me 6.25. Just double checking my work. Make sure I entered it correctly because it just seems odd. But okay, 6.25 times the cosine of A. Now, what a lot of people want to do right now is they want to take this, add it with this, and then subtract that. You cannot do that because of this cosine of A is like a variable. And what it would be like is it would be like if you had like 9 equals 1.5 plus 6.25 minus 6.25x. You have to add these first right here, okay? You cannot do anything with this. That's going to end up being divided by negative 6.25, okay? So be careful about that. That's a really common mistake that people do, that they get it wrong. So you got to follow your steps for algebra. And so, let's see if I can erase this. There you go. You have that cos. So the next thing you should do is take 1.5625 and add it with 6.25, and that gives you 7.8125 minus 6.25 times cosine of A, and that equals 9. So now I'm going to subtract 7.8125 from 9. So 9 minus 7.8125 gives me 1.1875 equals negative 6.25 times the cosine of A. Now I'm going to divide by negative 6.25. And that gives me that the cosine of that angle is negative 0.19. And now I need to take the inverse cosine of that. And so angle A is equal to 100.95. So it's an obtuse angle, 100.95. So we found our first one. Now we can actually use the law of sines to, once we've gotten one of the angles, now we can go ahead and use the law of sines, which is a lot easier. Now, depending on what angle you do first and how you round, you could get slightly different variations in this. But now I can set up, no, that's not a very great color. So now I can set up the sine of angle A, 100.95, over 3 is equal to the sine of B over 2.5. So now I'm trying to find angle B. Once I get angle B, then I can definitely use triangle sum, because you can see how much work these problems really are. So now I can cross multiply, which will give me 2.5 times the sine of 100.95 equals 3 times the sine of B. So now I'm going to need to divide by 3. And so now my sine of angle B is equal to all of this right here. And in order to solve, I'll have to take the inverse sine of each side. And when I do that, I'll take the inverse sine. And again, when you type this in right here, when you're typing all of this into your calculator right here, okay, you need to make sure you're including a parenthesis right here around that angle before you hit divide. Some calculators are different, but I'm going to take the inverse sine of 2.5 times the sine of 100.95, close my parenthesis, hit divided by, and then 3. And that should give me 54.90. So angle B equals 54.90 degrees. So now we have angle A, we have angle B, and so now we can use triangle sum to get C. We already have the 3 sides, so we don't need to do anything else with the sides. We are solving, which means find all the missing angles inside. So now angle C is equal to 180 minus 100.95 minus 54.9. So 180 minus 100.95 minus 54.90 gives us 24.15. Okay, so again, there's a lot of work to these. Okay, law of sines and cosines. You got to be careful. Okay, but most of the time, once you get one piece using law of cosines, you can use law of sines, triangle sum to get the rest. Again, there's a lot of examples here. This one's a little bit different. This one, the algebra is not as difficult. So this one I'm going to have you try on your own to see if you can actually set it up and solve correctly, and then check the notes. And I'll do one where they don't give you the picture of the triangle, again, to practice here, making sure we can set up the sides and angles appropriately across from each other. So actually, I'm going to do the next example, but I'll go ahead and label the triangle. So if this is A, B, C, remember side A goes across from angle A. Side B goes across from angle B, and C and C. This one is just like we did on example 1, where the algebra is trickier, so I'm going to actually have you try that one as well. I'll try one where we're given one of the angles, like was example 2 that you were also trying on your own. So again, if I'm given this triangle A, B, C, and I know angle C is 27 degrees, I'm going to find the angle C here in just, or side C in just a minute. But side A is 9, and side B, sorry, that side A is 5, and side B is 9. So I'm going to have to use the law of cosines because, again, if I try to set up, I don't have enough angles or information to find using the law of sines. So using the law of cosines for this, I'm going to use the c squared formula. So c squared equals the other 2 sides squared added together minus 2 times those sides multiplied times the cosine of that angle. So here's where I plug everything in. So c, we don't know. We don't know c squared. We do know a is 5, so 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of 27. So what really can happen now is you could enter all of that in one step because you have no unknowns over here. I'll go ahead and solve it kind of in pieces here. This is 25 plus 81 minus, and then this is 2 times 5 times 9, which is 90 minus 90 times the cosine of 27. Again, you don't have to do it in this many steps. You literally could type all of this right here in your calculator or above, either way, and then take the square root of all of that. I'm just working it out in pieces just to make sure that you can see what's going on. So 25 and 81 gives us 100. So I get 100 minus 90 times the cosine of 27. So 90 cosine of 27 is 80.19. And that's what equals c squared. So now c squared equals 19.81. So now I can take the square root of each side to get the approximate value of c. So I was only supposed to find c here, not solve the whole thing, luckily. And so my value of c is approximately equal to 19.81. So that gives you some practice on law of sines and cosines. And I know that there's a lot to it, but do your best. And then this is the last point I want to just point out. We're not going to actually deal with this too much, to be honest, because of the length of what we're already doing right now. But if you do have an obtuse triangle, it can be tricky. And so what you need to do is you need to use the law of sines to get 3 sides and at least 1 angle, and then use the law of sines or cosines to find the remaining angles. And after you do this, okay, you need to check for 2 things. If the largest angle is the largest angle across from the longest side, do the angles add up to 180? If the answer is no to either one of these questions, then find the angle across from the longest side and subtract it to 180. Okay, so you might notice if you do encounter any obtuse triangles, it's like, wait, I use the law of sines and cosines and now the angles don't add up to 180. So just keep that in mind. It's not going to be a real big piece right now. We have enough other things to practice at this point in time, but just want you to be aware mathematically what is going on. So that is the end of our chapter